Hi everybody, my name is Aditya and my partner's name is Atul. Our project is titled A Comparison of Methods for Devanagari Character Recognition. Devanagari is a script associated with the Eastern languages Sanskrit and Hindi. Our project seeks to explore different methods in solving the problem of handwritten Devanagari character recognition. We talk about the different architectures we use to attempt to solve this problem and finally conclude with a comparative study of the different models. Our dataset consists of 110 different character classes with around 18,000 total images. We formatted each image by converting it to grayscale and resizing it into a 28 by 28 pixel array, which served as the inputs to our architectures. Our first approach was to try deep belief networks. The table shows the percentages obtained with respect to the number of epochs. The best accuracy turned out to be 26%. DBNs are generally known to do relatively well in character recognition problems, and so this came as a surprise. Our second method aimed to use the benefits of CNNs. We set up a convolutional neural network with the following architecture and tuned the hyperparameters to improve the performance. The architecture on this slide is the final setup we chose, using 2D convolution, max pooling, and dropout layers. The final fully connected layer, of course, leads to 110 output scores. The prediction rates for the CNN architecture that we just described can be seen in the table. CNNs are historically known to do better with image recognition problems and, of course, handwritten character recognition. With these prediction rates, it was still clear that our CNN had not been trained sufficiently. Combine this with the fact that our DBN also had poor error rates, we concluded that our dataset didn't have enough training points considering the number of class scores and the very small variations between classes. To analyze this further, we decided to actually partition our dataset starting from as small as possible. The table above shows what happens when we allowed for just 2 classes. This achieved close to an F-score of 1 on the test set, of about size 2,500. We tried the same DBN with 3 and 5 classes and finally on a 10 class score set. For the 10 class score set, our F-score was only 0.59. This led us to believe that we needed a different way to perform feature extraction and perhaps partition the class scores such that each hidden node needed only a certain range of class scores to look at. This led us to our third and final architecture. The architecture we tried implementing was based on a variation of the CNN architecture and the results we obtained from the analysis of the DBN on different class sizes. We decided to partition the dataset and feed each partition to individual CNNs in a bid to reduce the number of class scores in the range of each node. This architecture may have outperformed the DBN as expected, but failed to surpass the regular CNN we had used earlier. We found that a regular CNN turned out to be the most effective way of attempting to solve the Devanagari character recognition problem. The usage of filters and pooling layers in CNNs helps in being able to target image-related inputs. That concludes our presentation. Thanks for watching.